I'm just going to review with you really quickly how to divide fractions, okay? So just see if you remember this maybe from like middle school or whatever. So if I divide fractions, it's the same as multiplying by the reciprocal. If I divide a fraction by another fraction, it's the same as multiplying by the reciprocal. So that's usually what we do to do this. And then if this helps you in any way, call this keep, change, flip. So for this problem, I just have a little example with numbers. I have 2/7 divided by 20/21. Okay, so literally all you do, you keep the original fraction, which is the 2/7. You change the division to multiplication, and then you flip the second fraction over. That gives you the reciprocal. So dividing by fraction, same as multiplying by the lovely reciprocal. And so when you do any multiplication, you don't need a common denominator. Just go straight across the top, straight across the bottom. This would be, let's see, 42 over 140. And then if we can reduce it, we will. I'm going to grab my calculator here real quick to do that. And I got 3/10 as the reduced version of that fraction. But the concept behind it is keep the original that you're dividing by, or you're dividing into, change the division to multiplication, and then multiply by the reciprocal of what you have. And we're going to do some factoring again today. Okay, now, in terms of the restrictions, what you have to use here is the same as for multiplying. Exclude any number that makes the denominator equal to 0. So we got to exclude any number that that makes the denominator 0. Specifically, when you are dividing, that is the original problem, bless you, and at any point in the problem. So in this case, if you are dividing, because we're going to do our keep, change, flip, so whatever the second fraction, whatever you're dividing by, okay, so whatever you're dividing by, you want to exclude anything that makes the numerator or the denominator equal to 0, because you're going to flip that fraction over, bless you. So in the original problem, whatever you're dividing by, the denominator in the original problem is a problem. But then you're going to flip it over. So that's going to put the numerator into the denominator when we do the reciprocal. So basically, whatever you're dividing by, exclude anything that would make the top or the bottom equal to 0. So it might have some extra restrictions here. Okay, now, here's what we've got going on in this lovely first problem here. I've got 20x minus 5y over x cubed y squared. And I'm going to divide that by this other fraction. So I'm going to change this to multiplication real quick. And I'm going to take this second fraction and flip it over. So the 8x cubed will go on the top. And the 12x minus 3y will end up going in the bottom. Okay, now at this moment, let me just write my restrictions to the side. In the original problem, if x was 0, that would be a problem for this top fraction, or if you want to look at it over here. Also, if y was 0, that would be a problem. And then before I flipped it over, I had 8x cubed. So again, x would be 0, but we've already taken care of that. Now, when I flip this over, I'm going to factor this a little bit, so just wait for that last restriction. But the only other thing that could make my denominator 0 is if this 12x minus 3y, but we're going to factor it a little bit before we answer that. Okay, now, I know I have two different variables. Do 20 and 5 have anything in common? 4 is going to be what we'll have left over, but they're both divisible by 5. So if I take 5 out of those first two terms, just doing a little greatest common factor, this will end up being 4x and then just minus 1y, or just minus y. You're not doing anything to factor the bottom of that because that's just a product right then and there. And the other fraction, after I flipped it over, do 12 and 3 have anything in common? 3. If you take a 3 out of both of those terms, divide them both, this will be 4x minus 1y again. And now, because this is a multiplication problem from flipping this over, this just turns into one lovely giant fraction here. And so anything that matches on the top and bottom we can cross out. So I have an x cubed and an x cubed, just one for one, just gone. And we have this 4x minus y, 4x minus y. And let me add that to my restrictions after I factored it. The 3 is not going to affect anything, but 4x minus y, we would not want that to be 0 because that would cause that denominator to be 0. Another way because it's involving two different variables here, another way you might see that restriction written is almost like they solve the little inequality, they'd add y to the other side, so you might see it written like that, 4x can't be equal to y. Both of those are fine with me, whichever one you like better. But that'll take care of all our restrictions there. And then what do I have left on the top? I have 5 and 8. This is being multiplied, so I'm literally going to do 5 times 8, so that's 40. And then on the bottom, I had a y to the second and a 3. And that's all we've got. We can't reduce 40 over 3, so that's going to be our answer for that question. Does anybody have any questions? Okay. Let me try and look at this next one and see if we can factor. Okay, can you, for that first lovely fraction there, think of any numbers that when you multiply them, you get negative 15, add them, you get 2. Plus 5 minus 3. So x plus 3. No. I just said that backwards. Minus 3 and x plus 5. Sorry about that. What about x squared minus 16? It's a difference of squares. Yes, ma'am. X plus 4, x minus 4. Okay, now I'm just going to keep this division just for 1 second so I can do my restrictions here real quick. And you can't factor the top of that fraction, which is x plus 5. But what about, do 3x and 12 have anything in common? 3. Okay, now I'm just going to take that greatest common factor out in front real quick. Left over, you'd have x minus 4, and that's helpful to get my restriction. So the only things making any of these denominators 0, we'd have negative 4, we'd have positive 4. And if you want to write plus and minus, that's fine too, to just save yourself some time. But then over here, it would be positive 4 again. I've already represented that, so I don't need to write it a second time. Okay, now I'm going to do my keep, change, flip. So I had this x minus 3, x plus 5. We had x plus 4, x minus 4. And then I'm going to change that division to multiplication. Flip this guy over. 3 times x minus 4 and x plus 5 on the bottom. This is just one giant multiplication question now. So if anybody matches on the top or bottom, we can cross it out. So x plus 5 here, x plus 5 here, x minus 4 here, x minus 4 here, and then nothing else matches. But when I did flip that second fraction over, I did introduce another number that we got to include in our restriction. So x plus 5, I don't want that to be 0. So negative 5 would be a number that we would want to use in our restrictions. And then beyond that, just write down what you have left. Please leave it in factored form. Don't need to FOIL or distribute or multiply. So on the top, I've got a 3 and an x minus 3. And then on the bottom, I have an x plus 4. Nothing else cancels out there. It's really similar to what we were doing with the multiply. It's just got an extra step because when you're dividing, you're going to multiply by the reciprocal. So you got to flip the fraction over. Okay. And then if you're working ahead of me, do me one quick favor. On the bottom of this, the second page, I had some review here from actually first semester. I'm going to see if you guys can remember how to do this. But do me a favor, just cross the 2 out that was in front of that x squared. That's not supposed to, or x to the 4th. It's just supposed to be, I'm not looking, now it looks like I added another x. Okay, just cross the 2 out. Just cross the 2 out. It's just supposed to say x to the 4th. So we're going to review on that question a little bit, see if you guys can remember some factoring stuff from first semester, but just in case you were working ahead of me. Okay. Can I factor on the top of this first fraction here, 4x squared minus 2x? Can I do any kind of factoring there? What do you think? Okay, so if you take out a 2x, what would you have left? There you go. Okay. Now, What might I notice about the bottom of the first fraction? Anything that those terms all have? Okay, 3. Anything else? And yeah, I've got at least an x in each of those terms. Okay, so then left over, we'd have x squared minus 2x, and then just minus 3. And I'm not trying to be all extra or anything. This can be factored into x minus 3 times x plus 1. So I pulled that. I'm just going to kind of cross this out here a little bit. So I'm just factoring that a little bit further completely, because we can factor that quadratic after we take out that greatest common factor. Okay, now I'm just going to keep this division for a second. Can you guys think of two numbers, multiply to get 12, add to get 8? 6 and 2, so x plus 6, x plus 2. Can we think of two numbers when you multiply them, you get negative 18, you add them, you get 3? Positive 6 and negative 3. Okay, now, before I flip anything, let me just write my restrictions as I can see them here. All right, so in terms of just the 3x, right? The x, if I would plug in 0, not 3, 0, that would be a problem. Okay, now, x minus 3, 3 would be a problem. X plus 1, negative 1 would be a problem. X plus 6, negative 6 would be a problem. And then x minus 3, I already took care of that from the first question, so I'm not going to cross anything else out. And at this point, within the same fraction, because I haven't done the division yet, if anything matches within the same fraction, we can cross it out. So for example here, the x and the x, everything's a product on the top and the bottom, so you can cross the x's out. That's the only thing. In this fraction, I can cross out the x plus 6's. Okay, now I'm going to flip this over. So then with what I have left, I'm just going to leave the factored form. They are going to cancel, but I got to flip it over first. Okay, so let's see. So I have 2x minus 1, and then we have x minus 3, x plus 1. Then I'm going to change this to multiplication and flip this over what I have left. So then the x minus 3 goes in the top, x plus 2 goes in the bottom, and just a little bit more cancels out here. So everything's being multiplied. The x minus 3 here and the x minus 3 here cancel, but everything else is left. And the other thing is, real quick, when I flip this over, I added x plus 2 into the denominator, so that's going to give me a negative 2 added onto my restrictions. So just be careful with that. And then our answer, we've got a 2x minus 1 on the top, and then I've got x plus 1, x plus 2 left on the bottom. And then again, go ahead and leave that in factored form. You don't need to FOIL that out or anything. Say that one more time. Oh yes, still at life. Okay, I forgot the 2 and the 3. The 2 here, the 3 here. So in my answer, I'm just going to put little parentheses around this. You don't need to distribute. Just leave the 2 and then the 3 down there. I forgot the 2/3. Just the x's canceled out up there. Okay. Now, let's see what we got going on here. All right. I actually think we factored one like this on the front. Okay, so x, let's see, we've got a plus 5 and a minus 3. And then we had a minus 4 plus 4. Nothing that's going to cancel out there. Now, let me see if you guys remember this from what we were working on last week. So if you see a term, like this says 12 minus 3x, how would you maybe manipulate the bottom of that? Yes. Now, in that case, if you want, what we could just do real quick, I'm going to take a negative 3 because both of those terms are divisible by 3. I'm just going to take a negative 3 out in front. If I do that, this would become negative 4 plus x, or probably a more comfortable way to write that would be negative 3 times x minus 4. So if you see something like that where your term with the x is negative, just factor out a negative 1, or in that case, I can just take out a negative 3. and then that'll make it so it might be able to cancel with something that you already have. So just took a little negative. So I'm just going to write negative 3 here, x minus 4. Okay, now at the moment, I can't cross anything out because nothing matches on the top and the bottom. But like I said, right here might be where I want to try and write some restrictions. So I don't want x to be 4 or negative 4. Now, the negative 3 doesn't have a variable with it, so that's not going to affect making my denominator 0, so don't worry about that. We are going to flip that second fraction over, though. So that'll put the x plus 5 in the bottom, so then negative 5 would be our only other restriction there. I'm just thinking, kind of thinking ahead about that. So this would be x plus 5, x minus 3, x minus 4, x plus 4. And then I'm going to change this to multiplication, and then to divide by the fraction is the same to multiply as its reciprocal. So I'm going to flip that over. And now if I'm multiplying, if I can get anything to match on the top and bottom, we can cross it out. All right, so in this case, I've got x plus 5, x plus 5, x minus 4, x minus 4. Now, I do have a negative 3 here and an x minus 3 left on the top, and just leave it in factored form. I would just put the negative 3 out in front, though. And then on the bottom, all we have left is x plus 4. And we already kind of were writing our restrictions as we went through the problem. Okay, now the last one has a little bit of review of some factoring from first semester. So I'm going to see if you guys remember this at all. This guy right here is called a difference of cubes. So x to the third minus 27. 27 is 3 to the third power. I don't know if you guys are going to remember this. So I'm going to write it real quick here. If you have a cubed minus b cubed, that can factor into a minus b times a squared plus ab plus b squared. That was the formula, and we gave that to you guys if we did any test or quizzes. So what would, for x cubed minus 27, what would you plug in for a and what would you plug in for b? What would you put in for b? 3. It's a cube root of 27. All right, so I'm just going to follow that formula. So it'd be x minus 3. Now, a squared would be x squared. A times b would be x times 3, so I'm going to be putting plus 3x. And then b squared would be plus 9. Okay. And we are not going to worry about a restriction on that x squared plus 3x plus 9, because I don't know if you guys remember this, but it's actually imaginary. What would set that equal to 0? So don't worry about that. Now, on the second fraction, do you guys notice all those numbers are divisible by 4? So I'm going to take a 4 out. Just a 4, no x or anything. This would be x squared plus 5x plus 6. So let's see, multiply to get 6, add to get 5. I'm going to do 2 and 3. Okay, now the last one. Remember I said it should not have a 2 in front of that x to the 4th. So that is x to the 4th minus 13x squared plus 36. All right, I don't know if you remember this from first semester, which is why I put this on here. Okay, so this factors just like a quadratic would factor. The only difference is we're going to use x squared instead of a plain x, because x squared times x squared will give you x to the 4th. That middle term will be the 13x squared. Can we think of two numbers that when we multiply them we get 36, add them we get negative 13? Okay. So those actually both end up being differences of squares. So this is x minus 3, x plus 3. This guy's x minus 2, x plus 2. So this last one was really lots of factoring in this, really reviewing stuff from first semester. So I'm going to factor all that stuff, and then we're going to see what we can cross out. But in this situation, do not worry about restrictions on this quadratic here because it's going to have an imaginary solution. We're not going to plug in any values of I for this. So for my restrictions, we got a ton of them here. So I've got 3. Don't worry about that quadratic. That has imaginary solutions. I already represented 3, so I'm going to represent negative 3. I'm going to represent 2. I'm going to represent negative 2. Now, on the top of this fraction, when we flip it over, that is not going to introduce any new restrictions, so I'm not going to worry about that. I can actually cross some stuff out right here within this same fraction. And then I'm going to see what we can do with the rest of this. So I'm going to keep this, 16, x minus 3, x squared plus 3x plus 9. I'm going to change this to multiplication, and I'm going to flip over what I have left. So left on the bottom of this fraction here, I had an x minus 3, x minus 2. And left on the top, I just had a 4. So we'll see if anything else will cross out. I can cross out the 3's, x minus 3's here. And I'm going to write this out, but if you want to skip this step, you can. So I'm going to write on the top 16 times x minus 2. On the bottom, I'm going to write 4, x squared plus 3x plus 9. And I can do one more thing there. Yeah, you can actually, the 16 and the 4, you can reduce that. So on the top, we're just going to leave a 4 and then times that x minus 2. That would just get rid of the 4 in the bottom. 16 divided by 4 is 4. We would leave that on the top. And then you'd have that x squared plus 3x plus 9 left over on the bottom. I know that last one was a lot, but there's one question like that on the homework, so keep that in mind.